Hey everyone, and welcome back to my channel. Today we are diving into Apache Hive, a game changer for everyone working with big data. If you know SQL and want to analyze massive datasets without headache of complex coding, then this video is for you. We will cover over everything from the basics to optimization tips. Stick around till the end of the practical example and a bonus tip on integrating Hive with other tools. Let's get started. Hive lives within the Apache Hadoop ecosystem, which is the foundation for big data processing. Think of Hadoop as the engine that powers Hive. Hadoop has two core components, namely Hadoop Distributed File System and MapReduce. HDFS is like a super organized file cabinet spread across many computers. It stores your massive data sets in a distributed and fault tolerant way. Imagine splitting a huge book across multiple shelves. That's HDFS. And MapReduce is a processing engine. It takes your data and breaks it down into smaller chunks, process them in parallel across those computers, and then combines the results. It's like having a team of librarians working together to analyze the contents of that book. Now here where Hive comes in. It provides a SQL-like interface on top of Hadoop. Instead of writing complex MapReduce code in Java or Python, you can use HiveQL, which looks a lot like SQL, to query and analyze your data. This makes big data analysis accessible to a much wider audience. Then, Hive is a component of SQL and Hadoop. That's the core idea. If you know SQL, you are halfway there. HiveQL lets you use familiar commands like select, join, var, group by, etc. to interact with your data. Hive leverages Hadoop's distributed architecture. This means it can handle petabytes of data and keep running even if some machines fails. And Hive excels at processing and summarizing large datasets. You can easily calculate, aggregate, and perform joins, filter data to get insights you need. Think of Hive as a translator that lets SQL speakers talk to the Hadoop world, and then Hive architecture and components of this. This is the client. This is where you write and submit your HiveQL queries. It could be a command line interface, a web UI, or a BI tool. And then it events to driver that receives your query and manage it execution and acts as a project manager. And then compiler translates your HiveQL into a series of MapReduce tasks. It optimizes the query for efficient execution on Hadoop. This component analyzes the query and determines the most efficient execution plan. And the executor runs the MapReduce tasks on the Hadoop cluster. Then the meta store is the central repository for metadata about your Hive tables. It's crucial for managing your data. The process flow was like if you write a query, the driver and compiler translate it into MapReduce tasks, and the optimizer makes it efficient, and the executor runs it on Hadoop. You get the result. And then we want to know about Hive data models and data types. These are like table, partition, and buckets. Table means it's in a relational database, they hold your data. And then partitions are the divisions of tables based on one or more columns, like data, region, that wise. This makes querying faster if you are only interested in a specific partition. Imagine having a library organized by genre. And then buckets are the further divided of partitions. This improves performance for certain types of queries, especially joins. Think of it as further sorting each genre by author. And the Hive supports wide range of data types like primitive data types. These are int, string, boolean. These are, and then complex data types, array, map, structure. And we are going to see about Hive query language. HiveQL is similar to SQL. It allows users to query and analyze data in Hive. HiveQL statements are translated into MapReduce jobs. The similar commands used in Hive also. Select, from, where, group by, join, order. These are used for retrieve the data, specify and filter, group by, and combine the data from multiple data sets. And if you know SQL, you will feel right at home with HiveQL. And then we are going to see about Hive partitioning and buckets. Partitioning divides a table into small pots, and the bucketing further divides the partition. Both improve query performances. And the use optimization file formats like ORC. These are helps for Hive partitioning and bucketing. And then we are going to see about Hive performance optimization techniques. These are file formats, configuration tuning, query optimization. File format means use of optimized file formats like ORC or Parquet. These formats are designed for efficient read and write operations. And query optimization is to understand how Hive executes queries and write your queries efficiently. Avoid full table scans if you possible. And also configuration tuning. This means it adjusts Hadoop and Hive configuration parameters to optimize resource utilization. These are the optimization techniques used in Hive queries can make a huge difference in processing time. And then we are going to see about Hive integration with other big data tools. Hive integrates with Spark, Presto, and other tools. This enables advanced analytics and data processing workflows. Use Hive with other tools in the data lake. Spark is used for in the memory processing and making some Hive operation much faster. And Presto is the another SQL query engine that can be used with the Hive. And HBase can integrate with Hive NoSQL database for more complex data access patterns. And then we are going to see about real world use cases and applications of Hive. Hive is used for logic analysis, data warehousing, and business intelligence. Retail, finance, and healthcare industries use Hive. Analyze large datasets and create reports. These are the real cases of Hive. And then in business intelligence, they are like in analyzing customer behavior, sales trends, market segmentation, and also maintaining and building a large data warehouses and processing web server logs, application logs. And then we are going to see about conclusion. Hive is a powerful tool for analyzing big data using SQL. It simplifies the process, making it accessible to a broader range of users. And then it is more scalable, efficient, and integrates well with the other tools in the Hadoop ecosystem. This supports multiple storage formats and execution engines. And then if you want to know more about, I want to know that, did you find this video helpful? Give it a thumbs up, subscribe to the channel for more big data tutorials, and leave a comment below. Let me know what you had like to see next, maybe on a next hands-on tutorial on setting up Hive and running some queries. Thank you for watching. See you in next video.